Hello students, welcome to Hydraulics and Hydraulic Machinery class. In today's lecture, we will discuss some of the problems related to the force exerted by a jet on a flat plate held normally, on a flat plate kept inclined, on a curved plate or vane where the jet is striking at the center, the jet is striking at one end. So these problems we will take up. In the previous two lectures, we have derived the equations for calculation of the force in the case of stationary flat plate held normally, stationary flat plate kept inclined position, a curved plate or vane which is symmetrical, which is stationary, and the jet is striking at the center. Whereas the jet is striking at one end, what is the force? The jet is striking at one end and the vane is unsymmetrical, what happens? So all these derivations we have done in the previous two lectures. Now related to these two lectures, these five cases which we have already studied, some problems we will do so that we familiarize on these principles. With that, I will take you to the lecture. But before taking to the lecture, in all these cases, if you remember, I told total five cases. Force exerted by a jet on a fixed plate held normally. First case. Force exerted by a jet on a fixed plate in the inclined position. Number two. Force exerted by a jet on a curved plate or a vane. The jet is striking at the center and the vane is symmetrical. That is case 3. Force exerted by a jet on a vane, jet striking at one end and the vane is symmetrical. That is case 4. Force exerted by a jet at one end, unsymmetrical, stationary vane. That is case 5. So all these five cases, we have derived the equations. That completes the calculation of the forces in case the plate or the vane is stationary. But in all these cases, we stopped after calculation of the forces. If someone asks you what is the work done in any of these cases, the work done per second is equal to force multiplied by the velocity. Of course, both will be in the same direction we should take. Force into velocity of what? Velocity of the plate or the vane. Unless the plate or the vane moves, the work done is equal to 0. So in all the cases right now, whatever we have dealt, the plate or the vane is stationary. So therefore, the work done is equal to 0. As long as the plate or the vane is stationary, the work done is equal to 0. Work done comes into picture only when the plate or vane starts moving with some velocity, because work done per second is equal to force into the velocity of the plate or the vane. It's a very important point that you should note. Now let me take up the problems straight. So straight away, we will take the problems on stationary flat plate or curved plate, and curved plate is also called as vane. What problems we will do? Calculation of force. This is the problems. So first case one we will take it. Force exerted by a jet on a stationary flat plate held normally. For this already we have derived the equation F is equal to rho A V square, where rho is equal to mass density, which is equal to 1000 kg per meter cube for water. A is equal to area of jet is equal to pi by 4 into d square, where d is dia of jet. V is the velocity of jet. So if you know this, you can solve any problem on this. Straight away, I will take it. Problem 1. A jet of water 75 mm diameter issues with a velocity of 30 meters per second and impinges on a stationary flat plate which destroys its forward motion. Find the force exerted by the jet on the plate and what is the work done. This is the question. So what data is given? Let us check up. Diameter 75 mm, velocity 30 meters per second, impinges on a stationary flat plate which destroys its motion. Find the plate, right? So now already I mentioned jet diameter D is equal to 75 mm. So it is equal to 75 into 10 to the power of minus 3 meters. So what is area is equal to, area is pi by 4 into d square. So therefore pi by 4 into 75 into 10 to the power of minus 3, which is equal to how much? Actually this is equal to point 0.00. Please check it up. Use the what you call it as uh, calculator. 4 and 1 8. Please do along with me. This is first thing. Once that is done, actually, for now it is water. So when it is water, rho is equal to how much I mentioned, 1000 kg per meter cube. So rho is over, A is over. What is the velocity they have given? It is 30 meters per second. So therefore, what is force is equal to rho A V square. Rho is 1000 into A is 0.004418 into velocity is 30 square. So if you calculate it, the force is going to be basically 3976.2 newtons. This is the force. So therefore, again work done is equal to 0 because the plate is stationary. As long as the plate is stationary, work done will be always equal to 0. So this is the first problem. So now we will do problem 2, case 2. I will take case 2. What is case 2? Force exerted by a jet on a stationary flat plate kept in inclined position. Second case. And we know the equations. So number one is Fn, we will calculate. This is called as normal force. Normal force is equal to, if you do it, it is rho A V square sine theta. Whereas then Fx is equal to Fn sine theta, which is equal to rho A V square sine square theta. Whereas Fy is equal to Fn cos theta, rho A V square sine theta cos theta. These are the things. So these are the basic things. In this, all others previously we know what is theta. Theta is the angle made by the plate, made by the jet better with the plate. So how we will represent it? Suppose if you take this is the horizontal line, how the jet comes. If you take this is the what you call it as the in plate kept in inclined position. So this is how the velocity will, and this is fixed actually. So now what will happen? This angle is called as theta. Direction basically this is, and this is theta. What is normal force? This is the normal force, which is normal to the plate, Fn. So naturally, Fn is like this. So this is what we call it as Fx. This is what we call it as Fy. So this is the thing which we are going to take up. Now straight away, I will go into a problem.
Like, share, and subscribe. Hit the bell icon for more updates.